This lesson is solving polynomials. This one it's a pretty tough lesson just because it involves so much of math that we've already covered and stuff from last year, and so it can get really confusing. So you can watch the videos as many times as you need to, and you can always ask me for help. Our learning target is I can solve polynomials. Okay, let's do the quadratic formula real quickly. So this is when you do that really annoying song. X is equal to negative b plus and minus square root b squared minus 4ac all over 2a. So if you've forgotten, a is the number in front of x squared, b is the number in front of x, and c is the last number. So I'm going to plug in accordingly, and whenever I plug something in, I'm going to put parentheses around it and then put the number in there. Oh, I should have done that in yellow, my bad. Alright, so I'm going to plug these in and I'm going to color code it so that you can see it a little bit more clearly. Okay, so there's that. I'll also post a video on just doing the quadratic formula in case you need extra help. Okay, then the next thing you do is you start to simplify. So when I have a negative in front of a negative 4, that becomes a positive 4 plus or minus square root. I'm going to take everything under that radical and put it in my calculator. Just don't put the radical around it. Alright, so you should get negative 44 divided by 2 times 3 is 6. Okay. I'll also post a video about simplifying radicals because maybe you forgot. So anytime you have a negative inside of a radical, you bring out the number I. I know it's a letter. I'm not dumb, but it's also a number I. It represents the square root of negative 1. And then what you do is you try to think of the biggest perfect square 44 is divisible by. So perfect squares are like 1, 4, 9, 16, 25, 36, 49, on and on and on. The biggest one it's divisible by is 4. And then 4 times 11 gives you 44. So here's what you do. The square root of 4 is 2. And I always goes after a whole number. And then since you can't take the square root of 11, it just stays 2i square root 11. Alright, so here's what you do. You're going to replace that radical with what you just found. So 2i square root 11 divided by 6. And then the last thing you do is you look at the 3 whole numbers. You don't focus on the radical or the I because they're just kind of there. And what are those 3 numbers divisible by? They're all 3 divisible by 2. So then you divide them by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. No need to write a 1. You can if it drives you crazy, it's fine. And on the bottom, 6 divided by 2 is 3. So that is how you do the quadratic formula. Alright. Alright, so we're going to do the same thing again. Quadratic formula. X is equal to negative b plus and minus square root b squared minus 4ac all over 2a. And my singing will haunt your dreams. You're welcome. Alright, so a is going to be 1, b is going to be negative 6, and c is going to be 9. So you can pause the video and plug them in. I'm going to do it and I'm going to color code it to help some people see it a little bit better. So here we go. Okay. And then we just start to simplify. A negative in front of a negative 6 is a positive 6, plus or minus square root. I'm going to do everything inside the square root, but not put the square root in my calculator. And you get 0 divided by 2 times 1 is 2. Alright, so this freaks some people out. The square root of 0 is just 0. There's no reason to do 6 plus or minus 0 because it's just going to be 6. So this answer, just becomes 6 divided by 2. Which is 3. Alright, so the previous problem, we ended up with 2 imaginary solutions. There they were. They were imaginary because they had an I. There's 2 solutions because the plus and minus. This one, we ended up with 1 real solution. Perfectly fine. Alright, and now let's do the quadratic formula one more time. And I'm actually going to change this to a minus sign. Sorry about that. Alright, this one can be a little misleading just because a is the number in front of x squared, so 1. B is the number in front of x. There isn't 1, so 0. And then c is the last number, the constant, negative 48. So x is equal to negative b plus and minus square root b squared minus 4ac all over 2a. Go ahead and plug them in. If you can, pause the video, try it. Alright, and now I'm going to simplify. X is equal. Negative 0 is just nothing, so I'm just going to disregard it. Now I'm going to do the stuff inside the radical, and on the bottom 2 times 1 is 2. And I get 192. So now I'm going to try to simplify 192. So I'm going to look for the biggest perfect square 192 is divisible by. So I got 64 and 3. So comes 64 and the square root of 3. The square root of 64 is 8. Can't take the square root of 3. So what I'm going to do is I'm going to replace the square root of 92 plus or minus 8 square roots of 3 over 2. Now, there are still two numbers that you got to look at. Disregard the radical. They're both divisible by 2. That's what we're going to do. So x equals plus or minus 8 divided by 2 is 4. And on the bottom, 2 divided by 2 is 1, so you can just keep it like this. So those are two real solutions. So that's the three things that can happen when you do these. You can have two real solutions, you can have one real solution, or you can have two imaginary solutions. If that was not enough for you, you can watch the extra video. But I want you to try this one, pause the video and actually do it. I'm going to have it worked out here, and then if you have extra questions, you can ask me about it. Alright, that's as far as you can go. You can't simplify the square root of 41, so there's nothing else to do. Those are two real solutions. Okay, so now we're going to look at solving polynomials. So I'm going to show you one way to do it, and then I'm going to show you another way to do it. Both of them are time consuming. It sucks. You just got to pick one. Okay, the first thing I'm going to do is I'm going to solve by factoring, because I can already see that this is a difference. It's kind of like the difference of squares. So I'm looking for two numbers that multiply to give me negative 81, but the adds give me 0. Those numbers are 9 and negative 9. 9 and negative 9. So my two factors would be x squared plus 9, x squared minus 9. Then I'm going to take the factors and I'm going to set them equal to 0. So x squared plus 9 equals 0. X squared minus 9 equals 0. I'm going to get rid of plus 9 by subtracting. X squared equals negative 9. And then I'm going to get rid of a square by taking the square root. X equals, the square root of 9 is 3. Because you're taking a square root, you do plus and minus. And because there's a negative inside the radical, it's 3i. So you have two solutions there. Then up here, you got plus 9. X squared equals 9. The way I get rid of a square is to square root. X equals, the square root of 9 is 3, and because I have a radical, it's plus or minus 3. So those are actually four different answers. 3i, negative 3i, 3, and negative 3. Okay, you can pause the video if you need more time. I'm going to erase it and show you another way to do it. Okay, the first thing you're going to do is you're going to graph the function and look for zeros. So remember, zeros are where it hits the x-axis. So go ahead and pause the video, graph it, look for some zeros. Alright, so I graph it on Desmos, and you can do this super easy. It definitely hits at 3 and negative 3, so x equals 3 and x equals negative 3. Alright, I'm going to get rid of this now. Step 2, we're going to use the zeros we just found to do synthetic division. Until we have a quadratic. Okay. So sometimes you may not find two zeros like we just did, but you can at least find one. Alright, so we're going to take, let's do this one first. We'll do the first one. Alright, so I know my 0 is negative 3, and I'm going to write out my coefficients. So the number in front of x to the 4th is 1, the number in front of x cubed, 0, the number in front of x squared, 0, the number in front of x, 0, and the constant, negative 81. So here's the process of synthetic division. We bring down the first number, whatever we bring down, we multiply, we add the column. we multiply, we add the column, we multiply, we add the column, we multiply, we add the column. Alright, so remember, last is our remainder, constant x, x squared, x cubed. So here's what I have remaining. Notice that this is not a quadratic, and my instructions say use the zeros to do synthetic division until we have a quadratic. We have a cubic, so now we're going to use the other zero. Okay, so we're going to take the remaining zero, the 3 one, and we're going to do synthetic to the cubic right here that we have left. Alright, so in our box is the other zero we haven't used, and then I'm going to write out my coefficients. So the number in front of x cubed is 1, the number in front of x squared, -3, the number in front of x 9, and the constant 27. I'm going to bring down the first number, I'm going to multiply, add the columns, multiply, add the columns, multiply. Just realized that there was a negative right here. Sorry, there we go. Alright, so now let me write what we have left. Remember, this is remainder, constant x, x squared. So we have x squared plus 9. We have a quadratic remaining. And so any quadratic can be solved with the quadratic formula. And we're going to do the quadratic formula. So x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Remember, a is going to be 1. B is going to be 0 because there's no x term. C is going to be 9. So I'm going to plug it in. X is equal to negative 0 plus or minus 0 squared minus 4 times 1 times 9 divided by 2 times 1. And now I'm going to simplify. So x equals a negative 0 is nothing, so it just goes away. I'm going to put the stuff under the radical together. Divided by 2 times 1 is 2. Alright, so remember, the square root of 36, I'm going to bring out an I because it was a negative, and I know the square root of 36 is a perfect square, it's 6, and I just always goes behind the whole number. So this is x equals plus or minus 6i divided by 2. And then you can just divide 6i by 2, and you get x equals plus or minus 3i. And then, don't forget, at the very beginning, whoa, we found that x equaled 3 and negative 3. Oh, I'm having a time with this. Okay. 3 and negative 3. So those are those same 4 answers we got by factoring, but that's the long drawn out process if you don't know how to factor. Yuck. Alright, now let's do this one. Okay, first step. Graph and find zeros. Okay, so pause the video, graph them, find some zeros. Okay, so it definitely hits at 4 and negative 4. So we know x equals 4 and x equals negative 4. Okay, so now we're going to use those to do synthetic division. So use zeros for synthetic division. And remember, the whole point of this is to get to the quadratic formula, so we need to make it become a quadratic. So I'm going to use this first one first. I'm going to put 4 in the box. I'm going to write my coefficients. There's a 1 in front of x to the 4th, 0 x cubed, negative 11 in front of x squared, 0 x's, negative 80 as my constant. I'm going to bring down the 1. I'm going to multiply and add. Multiply and add. Multiply and add. Multiply and add. So that's my remainder. Constant x, x squared, x cubed. Here's what I have remaining. I have a cubic, which is great, but there's no cubic formula. So I've got to break it down further using the one I didn't use. So we used x to the 4th, x equals 4, and now we're going to use the negative 4 to make it go further. Okay. So negative 4, and I'm going to write out my coefficients. 1, 4, 5, 20. I'm going to bring down the first number. I'm going to multiply, add, multiply, add, multiply, add. Alright, so that's my remainder, constant x squared. This is a quadratic. Any quadratic can be solved using the quadratic formula. X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. A is going to be 1, b is 0, c is 5. Alright, x is equal to, and negative 0 goes away, plus and minus. I'm going to do the stuff inside the radical, divided by 2. Alright, so it's going to become I square root to 20 because there's a negative. And then I'm looking for the biggest perfect square. 20 is divisible by, so 4 and 5. Alright, the square root of 4 is 2. I goes behind the whole number, can't take the square root of 5, so it stays like that. So x equals plus and minus 2i squared root to 5 over 2. Now I'm going to look at the two whole numbers. They're both divisible by 2, so I'm going to divide both of them by 2. Okay, I'm all right over here. I can't get it to move. So x equals plus or minus I square root of 5. And then don't forget at the very beginning we found a 4 and a negative 4. So all of those are answers to the polynomial. Alright, so you can try this one if you want to. Number 1, you're going to graph and find zeros. Number 2, you're going to use the zeros to do synthetic division until you get it to a quadratic. Number 3, you're going to use the quadratic formula. So you can pause the video and try it on your own, but if you don't feel like you're ready, then just wait and watch this. Okay, first thing I'm going to do, graph and find zeros. Okay, so definitely it hits at negative 8, and this time there's only one 0, and that's perfectly fine. So now we're going to use that 1 0 to do synthetic division. 1, 6, negative 14, 16. I'm going to bring down the 1. I'm going to multiply and add, multiply and add, multiply and add. So I'm left with x squared minus 2x plus 2, which is awesome because it's a quadratic, and I'm going to use the quadratic formula now. Alright, so I'm going to have to erase this because it's not letting me move the screen up. So you can pause the video and keep copying, but I'm going to have to fix it. Okay, so I moved it up and I simplified. Okay, the square root of 4 is going to be, it's going to be an I definitely because it's a negative, and also the square root of 4 is 2, so it's a perfect square. So x equals 2 plus or minus 2i over 2. Remember to look at all of the numbers. They're all divisible by 2, so I'm going to divide them all by 2, so 1 plus or minus I. And then don't forget at the very beginning, we found a negative 8. I know that's a lot, and it's overwhelming, and I get it, and you probably need extra help, and that's fine. You can ask me for help. Okay, the last thing we're going to do is we're going to look at 2 EOC problems. Okay, so you get this function. It tells us it has factors at x minus 7, x plus 4i, and it wants to know what are the total number of real zeros. So real zeros or where it hits the x-axis, and you just count them. So you need to take this function, plug it into Desmos, and count how many times it hits the x-axis. That's really all it's asking. Go ahead and try that. Sorry. Okay, so it hits the x-axis 1, 2, 3 times. The answer is 3. So it looks like it was going to be that whole long drawn-out process, but because it said real zeros, all you gotta do is count, which is awesome. Alright, one more. Alright, so you have this function. It tells you it has a 0, negative 1, and it wants to know the other ones. So if you know it has negative 1, you can just do synthetic division. Bring down the 1, multiply, add, multiply, add, multiply, add, x squared plus 2x minus 4, and then do the quadratic formula to figure out the others. So pause the video, do the quadratic formula. Okay, I know this is a lot, But really, the only things you're doing are graphing and finding zeros, using synthetic division, or the quadratic formula. So figure out what you're having trouble with, and then go watch those videos, and then you can ask me questions. But figure out where you're having trouble, and then fix it. And if you can't, I'll help you. So there's a haiku assignment. You're going to work out these. Try your best, and let me know if you have trouble.